All right, so I think we were looking at number 3, which is talking about a sphere. So we put the equation down for a sphere. So the volume of a sphere is 4/3 pi radius cubed. So I was using x, so I'm just going to use v equals 4/3 pi x cubed. So if I'm taking the derivative of the left-hand side, it's just like if it was a y. It's equivalent to dy dt. This is my derivative of volume with respect to time. When I find the derivative on the right-hand side, my variable is x, so I'm going to, and again, 4/3 pi, this is just a constant. When I multiply these, I would get 4 pi x squared. And I get dx dt. Now, previously we were finding the derivative of x with respect to x. We'd say dx dx, and we wouldn't write it. Now we're doing it with respect to time, so those are different. My rate of change, my change in x over change in time, they are not the same, so I have to write it. Now, the question that I said find the rate of change of the volume when the radius is 7 inches. So they told me, I'm trying to find this, my rate of change of volume. So I have 4 pi. X stands for my radius. Well, they told me my radius is 7 inches. And the rate of change of my radius, they told me was 3 inches per minute. So I have everything. To find dv dt, I just multiply it out. So I have 49 times 3, which is 147. And then 147 times 4 is 588. Now, if I wanted an approximate answer, I could multiply it by 3.14. But I think they're looking for the exact answer, and so we will keep the pi in it. So we have our equation, and we take the derivative of it. Again, the derivative of volume is dv dt. The derivative of my x is multiply it by 3, and then subtract 1 from the exponent, so we're using the power rule. But make sure we have the dx dt because it's with respect to time. And then we fill in what they've given us. The other one that we were going to look at was number 5, and this was with the ladder that we had. They said that the length of the ladder is 25, the hypotenuse in this triangle. I said we were going to treat this like x and y. They told me that the rate of change horizontally was 2 feet per second. So they've given me a rate, and they wanted me to find that rate as how fast it's coming down the side of the wall. So I had suggested maybe a x squared plus y squared equals radius, or hypotenuse squared. So we have a Pythagorean theorem. X squared plus y squared equals radius squared. Not radius, sorry, hypotenuse squared. So, which 25 squared is 625. So if I was taking the derivative of this, I would have 2x dx dt, because again it's distance per time. And then my next one would be 2y dy dt. Now what's the derivative of 625? It's a constant, right? So the derivative of constant is 0. So now I am trying to find this dy dt. So let's just move everything to the other side. So I have dy dt. I'd be subtracting that 2x dx dt, and then I would divide everything by that 2y since it's multiplying. Alright. And so now let's see what they gave me. They told me, they said that my rate of change, again, horizontally was 2 feet per second. So I know dx dt is 2 feet per second. feet per second. What is my x and my y? Well, on the question A that says when it's 15 away from the feet away from the house, when the base is 15 feet away. So that's what x is. So I have 2 times 15. But they didn't tell me what y is. Because I need y, right? I need to know what that is so I can find the rate of change of y. Well, if we go back up to our triangle, if I tell you that this is 15, can you not tell me what y is by using this Pythagorean theorem? I have a triangle. So, sorry, what I should have is 25 squared. So a squared plus b squared equals c squared. So 25 squared minus 15 squared is 400. And if I take the square root of that, that would give me 20. That is my height of y. So again, a squared plus b squared equals c squared. I don't know my height, but I do know the base of my triangle, and I know the hypotenuse. So I'm going to end up with a squared equals 400, a equals 20. So now I can put in my 2 times 20 here on the bottom. And then from here it's just doing the math. I get negative 30 times 2, so negative 60 up top, and 40 on the bottom. So I get negative 1.5, and I believe our units were feet per second. Now the reason why it's negative, our ladder is going down, right? So my x was going in the positive direction, my y is going in the negative direction. So then I think it has you do a couple different scenarios, and so just make sure you do them similarly. Looking at their answers, it says how fast is the top of the ladder moving down. So since it said down, I don't think we really need to put the negative sign. We just, down is referencing the negative. So we would just put 1.5 feet per second.